next week when I see you Tuesday, probably. Okay? So today we're going to finish the notes. I don't know if we're going to have time to do all of the assignment. We'll get started on the assignment. And next day, we'll finish off the assignment, maybe work on extending and do a quiz from that. And, well, maybe next week, Thursday then. We'll see. See how it kind of unfolds. Next week will be the test. All right. So, a review, sort of what we were doing. That's what day 3 is all about. It's more of a connecting all the things together. Right? So, what we have here is you're always going to give a relationship between two things. And that relationship holds true. You can use it to find missing numbers. Okay? Now, there are 2 ways we can use these relationships. One is called setting up ratios. Those are your fractions. The other method is called a unit rate, which we did a couple of questions right before we left. Right? So we're going to start off with working with ratios and fractions. Those words are sort of interchangeable at the moment. They're not quite exactly the same thing. Okay. And then we'll do it with a unit rate as well. All right, now, fractions and ratios, I think there is less likely you making a mistake, but sometimes maybe not the easiest approach. So here we have a scenario. We have 72 players on 8 baseball teams. Determine the number of players on 2 teams. Okay? So we can do this 2 different ways. First, we're going to set it up as a ratio, as a fraction. Okay? So, to do that, we have 2 fractions. 1 equals the other fraction. Okay? We need to take the information out and set up the fractions. So the information that's connected goes on the same fraction. For example, in the green here, that 72 and this 8 are connected. Because they're saying 72 players on 8 teams. So those 2 stay together. Right? Now, sometimes it doesn't. Something matter, David? It matters what you put on the top, what you put on the bottom. Sometimes it does. Right? If you have questions involving money, remember, money always goes on the top of the fraction. If you have a question involving time, time always goes on the bottom. Other than that, sometimes depending on the question, it does make a difference or not, but those are the general rules. All right? Here, we're not talking about money, we're not talking about time, so the order doesn't really matter. So, I take that 72 and the 8. There are both talking about the same situation, so those are going to stick together on the same fraction. So 72 and 8. Now, that's a fraction. To have a ratio, we need to put the units on. These fractions should have the same units, and this isn't the same unit, so that's kind of a no-no. You can get away with it by calling it ratios if you put the ratio, put the units on. So this is players, and this is teams. And I think this is actually the better thing to do because you're less likely to make a mistake. Because on the other fraction, now we put a number down. We have to put down how many players are on 2 teams. We need to put the number 2 down. So it makes a difference now. Do you put the 2 on the top or on the bottom? Yes, Adrian.
I can't find them.
Okay. Right? You don't have a green book thing on the side? I thought you did. That's the one up there. Alright? So where does that 2 go? Does it go on the top or does it go on the bottom? On the bottom, because we put teams on the bottom on the left-hand side. So teams needs to stay with teams. So I'm going to put 2 teams here. Right? Teams with teams. Now, if the other one, if we had the numbers the other way around, then they'll have to go the other way around over here. Yes?
Let's put the 36 on top of the 2.
The 36. Oh, that we're trying to figure out. So this is our blank. So we're going to put in a little X for something that we don't know. And Jaden's already figured out the number, but sometimes you don't see the number, right? So when these fractions are equal, remember the path, go from left to right. is the same. So you look at your numbers, you go, to go between the 2 and the 8, what's our relationship? Do we multiply by what number? Yes, person?
You have to divide 8 by 2, or divide 8 by 4 to
Yeah.
get to
Right.
two.
So, if you're not sure what the relationship is, you can always use your calculator. You go big number divided by small number, so 8 divided by 2 gives us 4. Now, sometimes this is a times, sometimes this is a divide. If the number going towards the blank is getting smaller, then you're dividing. If the numbers are getting bigger, then you're multiplying. So we are dividing because the numbers are getting smaller in this direction. So to go over here, we have to do the same thing. So you go divide by 4. So we grab our calculator out. We go 72 divided by 4. What number do you get?
9. Or 18.
18. Is it 18? Yeah. So then we can put 18 here. So then we say there are 18 players.
Why did we put an X there?
I did, I just solved it. There was an X. You can have the X here, you can put the 18 on top if you want. There are 18 players on 2 teams. Okay, this is called ratios. I think this is like the easiest way to set up a question. You just gotta be careful that when you're landing it for fractions, you have the information kind of synced up. Teams are both on the bottom, so they both stay on the bottom. Players are both on the top, they both stay on the top. All right? Okay, so this is called ratios. There's another way, it's called by using a unit rate. Unit means for one. Right, so we did some of those calculations last time, finding what was the best deal. We found, oh, what's the best deal for 1 milliliter of juice? What's the best deal for 1 penguin? Or what's the best deal for 1? It makes it easier to compare, right? So by doing a unit rate, if you find the value per 1, then you can use that for future calculations. Right, you do this a lot in physics. So this is method 1. So we go like this, I'll do a little squiggle line here. That was method 1. Method 2 is called a unit rate. Okay? To do that, you use the information that they give us. There are 72 players for 8 teams. So we write that down. 72 players per 8 teams. We take our calculator, we divide these two numbers together. Right? So 72 divided by 8, can you do that in your head? Jaden? 9. So this gives us 9, the units, players per team. So now if we divide, this is our unit rate. So we know that each team has 9 players. So if you want to figure out how many players are on 2 teams, just going to multiply it by 2. If you want to find out how many players are on 3 teams, you're going to multiply it by 3. So that's the benefit of the unit rate. You find it for once, and it's a little bit easier after that, right? And it's all calculator work too, right? So on 2 teams, so you go 2 teams, so times 9 players gives us 18 players, right? So either way, right? So unit rate, especially in grade 8, we mainly use it for finding what's the best deal, but you can use it for any of these kind of questions. Because they're always going to give you a pair of numbers. You find it for 1, and you just multiply them, right? Okay, so I'm going to jump around, hopefully to make this a little bit faster. All right, so now you pick and you choose, right? Which method do you want to do? It'll be hardly a situation where I ask you to do both, right? Here's another situation here. A potato farmer can plant 3 potatoes in 0.5 square meters, right? That's how much space 3 potatoes take up. But he's got 85 square meters. So how many potato plants can you have? So you can set up with fractions, or you can set up with unit rates. Now, whenever there's a question with decimals in it, I think unit rate usually works out easier for students. You can do it both ways. So we'll just do it with a unit rate. We'll do it the other way. So they gave us this information here. There are 3 potatoes for this much land, right? Remember the per means divide. So we go 3. Oops, get rid of this. 3 plants per this much land. Right? Now we grab our calculator out and we divide those two numbers. Right? What's 3 divided by 0.5? Can you guys do that in your head? Gosh?
Yeah, 1.5.
Not 1.5. Good guess. 6.
How do you get 6 from that?
Huh?
If it's 0.5, you double it.
Yeah. You're dividing it by half. Right? So this is 6. The units are important. 6 plants. So the top unit gets written first. This bottom unit gets written second. 6 plants per this much land.
Go.
Yeah.
I heard about it earlier and you go.
After we're done our notes.
That's kind of inefficient.
Huh?
That's kind of inefficient.
What do you mean inefficient?
No, I
Half square meter is actually a potato. Square meter. It should be able to count more than 3 potatoes.
I don't know. You gotta grow plants, so half a meter is this much space. So this, by this, by
I
this.
know.
Right?
I know.
That's how much it takes?
So that's square.
Yeah.
square.
So 0.5 this way, 0.5 this way, right?
You should be able to count 4. Actually, like in a
4?
I don't know.
Yeah.
Okay, so based off this information, you can get, gosh, your land is 85 square meters. So how many potato plants can this farmer have, right? If you have 6 in 1, 6 plants in 1, so you go 85 times 6 plants per square meter. How many plants do we get? 510, thank you.
I get 510.
510 plants. You multiply those two numbers together, right? That's it. So,
Yeah, I knew that.
the farmer can have 510 plants of potatoes. Right?
It's a lot of potatoes.
It is.
And like each
I like
potato
potatoes.
plant gives out like 10 potatoes.
Yeah, they make
That's a lot of
potatoes.
french fries.
Hey, it's a cheap food. There's a reason why potatoes are a cheap food, right?
A lot of McDonald's.
Right?
All the fries.
All right. Okay.
Callaway.
Yeehaw.
Really Sean Cogus.
No, Sean Cobus is Sean Cobus.
I know. No one can be.
Let's skip that one.
Falling out of a tree.
I should do this one.
It's on
Okay.
someone's story.
Here's another question. Electricity costs 11.58 cents for every 2 kilowatt hours. That's how you read that, KWH. Right? If you have 30 kilowatt hours used, how much money does that cost? Right? So, little story for you.
100 and
I have young kids.
I love their kids.
Yeah.
no.
And we would get one of those little pop-up Canadian Tire pools. We put it up, right? And Every summer we put it up. We've had it for like, I don't know, 8 years now since my kids were babies. So my kids are skinny little kids with very little fat on them, so they get cold easily. My son's backyard doesn't have a lot of sun in it. So I had to figure out different ways to heat the pool. Right? There's different options. You can use solar heat, you can use electricity heat, right? And you can use gas heat, and everything has a different cost to it. Right? So I did this calculation to figure out what would be the cheapest way for Mr. Dhaliwal to heat his pool. Alright, so now we have 3 pieces of information. Notice, usually in the same sentence, 2 of them are connected. So the 11.58 cents for 2 kilowatt hours. Those are connected, right? So those are going to go on the same fraction. What goes on the top? The 2, does it go on the top or the bottom? Bottom. Money goes on the top. Right? So we're going to put 2 on the bottom. 2 kilowatt hours. 11.58 cents here. Okay. Where does the 30 go? On the next fraction. Top or the bottom? Math. Bottom. Kilowatt hours with kilowatt hours. Write your units in so you can spot that they're the same. Okay. So now, you got to figure out how do you jump from one fraction to the other. It's always going to be multiplying or dividing. So you pick the 2 numbers you know. 2 and 30. What is the relationship between this?
They're even.
30.
You're gone.
06.
Multiply by 15. Like 2 times 30, 15 is 30.
15 is even.
So,
Is that the first thing that you can think of
why are you guys talking?
I'm dying here.
So, we got to multiply the top by 15 as well. So, what's 11.58 times 15? 172? 73?
Oh, I was so close.
0.7 cents.
So
So, we can say it costs 173.7 cents, or you can say it costs $1, if you round that up, 74. $1.74 to use 30 kilowatt hours. All right. Okay. So, all of these questions, what are you doing? Sit around. You haven't taken any notes. Come on. All these questions will be the same. You'll be given some sort of scenario. Hard part. It's a word problem. You got to read through it. You got to set up your 2 fractions or create your unit rate and just figure out what the missing number is. All right. Let's do. I don't think we need to do all of these.
No.
Sometimes we're not quite ready there. I want to do a couple of questions with you on the back side.
That was longer.
We're done when we're done.
That was longer.
Okay, if we have 3 fractions, but they're all connected with equal signs, that means the relationship between the equal signs are going to be constant, right? So you can pick any 2 to jump between. Okay, these 3 are all equivalent. If I want to figure out what this equal sign is, I need to pair it up with a fraction where I know both the top and bottom. On this one, you have to use the middle one. Yes, try.
I think I know what it is.
Before. Alright, so we're gonna.
48.
Shh. It is not 48.
6.
I know.
Questions. Question.
It's actually 36.
Quiet, please. Don't yell out. Raise your hands. Okay. So, you need to connect it up with the fraction where you know both the top and the bottom. Now,
Oh, I know it.
you find the path. You go, okay, I know between these two, what number do you have to multiply or divide, Gage?
6.
6. And it's getting smaller, so you're dividing by 6. So that means we need to divide this by 6,
4.
which is 4. So now, for the last question mark,
Could be 9.
hold on. The last question mark there, we can pick any fraction we want. The other two fractions, we have both the top and bottom. So you can make the connection between either one. Now, I encourage you to use the one where they gave you the both top and bottom in the question originally. That means maybe you made a mistake here, and if you use that mistake to figure out this one over here, that means you made 2 mistakes, you're more likely to get it wrong. But use the fraction that they give you in the question, but technically any of them work. We'll talk about that in a second. So, to go between here and here, because that's what we have. What do we got to do? Divide by 2. To go from here to here, that means we need to do the same. Divide by 2. And what number do we get? 9. Shh. Now, like I was saying, you could have picked the other fraction. Right? So if we chose the 4, we could go, let's pick, this would be 4 to 12 would be times by 3. Right? Then to go from here to here, we have to times by 3. And you still get the same answer. Right? So you can pick anything you want, but I suggest using the ones where they give you the question, just in case you made a mistake in your first calculation. That's it. Right? All right. Time is it? All right. I think we're good. I think rest of the class.